As you might have guessed from the title, this week's video is going to be something of a matter of opinion, because a few weeks ago I did a video, and if you saw it, I was converting an existing Blazor application into WPF, and I was finding that the XAML within the WPF was a little bit clunky compared with what I could do with the technologies we had in Blazor. And obviously that's partly because I'm so much more familiar with web technologies. I haven't done WPF seriously for quite a few years, but I think also there are fundamental issues with the way that XAML works that makes the web-based approach rather better. Now, quick bit of history of all this. Obviously, WPF wasn't the first way in .NET we could do desktop applications. That was the thing that came with the original .NET called WinForms. And if we take a quick look at WinForms, you can see the sort of thing we can do with it. So here I've just created a brand new empty application, and what I can do is go to the toolbox, I can drag on a button, position it, and that's the sort of way you edit with WinForms. And although that works very well, there are a few problems it may have with it. One of them is that it's based on quite an old technology in Windows called GDI+, where GDI stands for the Graphics Device Interface, and basically it means you're very limited in the sort of more advanced manipulations you can do, like 3D and that sort of thing. One advantage that WPF has, it's based on DirectX, the 3D graphics engine that's part of Windows, and that allows you to do much more exciting things. But another big difference is the way that you actually program it, because you've seen there I have done drag and drop to create that form. But if we actually look at what's happened there, if we look into the code here, you can see that that has simply caused the generation of some C#. So there we can see the C# generating the button that I dragged in, and there you can see the form itself. And C# is a programming language. It's not a language primarily designed for putting together GUIs. And so maintaining this sort of thing in code is very, very tricky indeed. You very rarely touch that code directly. You spend most of your time doing the drag and drop. So it's not so easy to manipulate at the low level. When you're designing GUIs, as we've learned from years of experience with the web, it's much better to have a markup language. And in the case of the web, that's HTML, the hypertext markup language. And so when WPF was introduced to .NET, they introduced this idea of XAML, the extensible application markup language, to do the same sort of thing. And so now if we switch to looking at some of that, this is back in the application we've been working on over the past few videos for rock, paper, scissors, rather than create something new. But if we look in the WPF client there we can see the XAML, and the point is you still get the visual designer. That's something nice that you don't get with things like Blazor or many web technologies, but you also get this much more appropriate code, and you typically tend to do editing as a mixture of visual editing and also coming in here to do some low-level work. Now that's all quite good, but even so, I think they made a fundamental mistake when they put XAML together. Because if you think about how the web works, with the web you have three separate languages. You have HTML for the markup, you have CSS, cascading style sheets, to do styling, and then you have the programming language to actually do any programming work. Traditionally that's JavaScript, but since WebAssembly has come along, we can use other languages like C# in Blazor. But when it comes to XAML, XAML is both the markup language and the styling language, and that's one of the things that makes it really clunky. Let me show you what I mean. If I just zoom in there so we can see that button a bit better, and then something you can do, which is really nice, shows both the power of the visual editor and the fact we're using DirectX, is if I go to that button, then I can actually just rotate it. And so we can get a button at an angle, which is really neat. But if you look at the XAML that's been created to do that, you can see it's really very complicated. So here's our button, and inside the button we've put this button.render transform, and then a transform group, and then a rotate transform. You can also see another problem of having a visual editor. It creates too much code, because the scale transform and the skew transform and the translate transform, it's put in there, but we're not doing anything with them, so we can just delete those. That's not the issue. And then we could change that to something more likely what we're after. Let's make that 45 degrees. So that's all okay, but it's still a lot of code to do something pretty simple. In fact, probably more code than just the button itself, as you can see. And beyond that, also, we've only applied this to the one button. When you do things with styling in HTML, you tend to create a class or something like that. Well, we can do that actually, because what we can do is if we go up here, we could do this in a separate file, but I'll just do it in the same file here. And then we can introduce a style. So we say style, and then we just give it a name. So we put in a key, and we'll call this rotate. And then we've got to say what it applies to. So we do a target type, which is going to be button. And so we have that. And then in there, we have to put this thing called a setter. And then we've got to say what property is we're going to change, which is going to be this render transform. And in there, we've got to put a setter value. And in there, we have to put a rotate transform. And then we can put an angle, which is going to be our 45 degrees. And so that's what we've got to put in there. And then once we've done that, we can take that style, and in the button, we can get rid of all of that. In fact, we can make this a self-closing element once again. And then we can just put in this a style. And then we've got on that, declare that it's a static resource. And then we can see finally it's listing that static resource of rotate. And you can see back in the visual editor, that's worked fine. But that is a ton of code to do something as simple as a 45-degree rotation. All that code there, all of this, calling it a static resource, having to match it up to a particular target type, really quite a lot of work. If we just do the same thing in our Blazor, we'll go into the CSS. I could do this with CSS isolation, but I might as well just use the global one to keep it simple. We'll go to the end of that, and then all I need to do is say something like dot rotate. So dot, because we've got a class, and then in there I can just say transform, and then rotate, and then 45 degrees. And so you can see that is so much simpler than what we've got in there to do the same thing, chiefly because XML style languages are just not appropriate for things like this, whereas CSS is really good for that. And then all we need to do is go to the home page itself, and there's our button. It's already got a class section. So we just put on that other class of rotate and then run that up. Slight problem there, of course, we don't have the visual editor again, so we do have to run it up to see the results. But when we do that, we can see that there we've got our rotated button. Very, very simple. So to do that sort of thing and all sorts of other bits of styling, it really is much, much simpler, I would say, in CSS than in XAML. The other thing we've got, though, is how we interact with our programming language, because the problem I was hitting when I did this in that earlier video was in order to do certain manipulations, I had to have these converters. Like, for example, I had to have this phase converter because I had a phase that was an enum that, if we just look in here, was either going to be welcome or waiting or playing. And in the XAML, I had to turn that into this stack panel where we did a binding of that phase onto this converter, this phase converter, and it was only in the phase converter that I could write the appropriate C# to turn my phase enum into the visible or collapsed that we had to show the stack panel. And that's because you can't embed C# into XAML. You've got to write your C# completely separately and then do something like that with the static resource in order to hook it up to your XAML. Whereas with HTML, from the beginning, you've been able to embed little bits of JavaScript directly into the HTML, and with libraries like Angular and React, that's become even easier, and it's also very easy in Blazor. So again, if we look at the Blazor, the way I achieved the same thing, I could just put a switch statement into the markup and then have the switch for welcome or waiting or playing, and not have to have these separate classes to do some very trivial code, but with a huge amount of boilerplate in there. Now, I think the logic behind why XAML was done like this was because this is the thin end of a slippery slope, in that if you start allowing C# to be embedded into the markup, you'll end up with business logic in the markup, which is a bad thing. But personally, I think you've got to leave it to the judgment of developers to use the right amount and not just ban them completely from putting code into the markup, because that's where we get this enormous amount of boilerplate that you can see in XAML. Now, that said, if you want to do a desktop application, well, surely you've still got to do it using WPF and XAML. We can't really have Blazor on a desktop. Well, actually, that's what the rest of this video is about, because you can. And one way that you can do it fairly easily is if you create a new project, you can go for a Maui Blazor hybrid app. So Maui is the multi-platform application user interface, and it's the latest way in .NET to write an application that will run on Windows or on Linux or on iOS and all sorts of other platforms as well. You can write those using XAML, but you can also write them using Blazor. So if we just bring that one up and go to next and just call this Maui Blazor demo and just go through the motions of that, what you'll see when this comes up is, although we've got this main page written in XAML, that contains very little. It just contains this Blazor web view, which ultimately takes us down to the Blazor components that you can see we've got in here with things like pages, and we've got a home page there just with a hello world. And so although this is an application that's using XAML, the XAML immediately defers to the Blazor. And so if we run that up, and then I'll just drag over the window, but you can see there we've got that hello world, all of that working in Blazor. So that's really nice, all works pretty well, but it does have the slight drawback that it is a MAUI application, a multi-platform application, and therefore if you just wanted to run on Windows, you're paying a bit of an overhead for all the other multi-platform facilities. So what would be nice is if we could just have a plain old WPF application, but still embed Blazor in there and have that working just on Windows. And that's what we can do. So let's go back to our rock, paper, scissors application. Let's just tidy up by closing down those tabs. And then into here, we're going to add a new project. And this will simply be a WPF application. So there we've got a WPF application. And we're going to call this Blazor WPF client. So merging those two technologies together. Click next on there, just go create with that. And then you can see it just gives us our blank window to start with. Next thing we're going to do is we're actually going to drag over all of the code from the original Blazor client that we need to make this work. So in order to do that, first I'm going to create a couple of folders. So I'm going to have a folder called www.root, just like we have in the Blazor client that we can see up there. And then I'm also going to have another one, which I'll just call components, just so that we can group together all the Blazor related stuff and keep it separate from everything else. And so what I'll do for the www root, I want the CSS, I want the library because we want the bootstrap in there. Don't need that sample data, should really have deleted that anyway, but we'll have the others, particularly the index, really important one that we need, and we'll drag all of that into www root. And then similarly, we're going to need the layout and the pages and the imports and the apps, all of that Razor stuff, and that's what I'm going to drag into the components. So that will mean that we've now got the things that we need inside our Blazor WPF client. Still going to need to do a few other things. So one thing we're going to do is add some NuGet packages. So the main one that we need is we're going to need the one that actually gives us this ability to embed our Blazor into our WPF. And that one is called webview.wpf. You can see it there. And so we'll grab hold of that one and install it. And then the other one I'm going to need, which isn't specifically to do with what we're doing here, but it's because we were using it in the original Blazor application, because we need to get hold of SignalR so that we can run the SignalR client. So we go for our SignalR client once again in there and approve all of that. Having done all that, let's now go to the actual project file, the CS proj. So double click on that because we're going to need to make some changes here. But the first thing you'll notice is it has added in a huge amount of stuff when I copied over those files. You can see each one of those has got its own content section. And we don't need any of that. I'm not sure if it does any harm, but it just makes things untidy. So let's highlight all of that and then just get rid of it. And now we can see the basics. So there we've got the two NuGet packages. But then at the top here is where we need to make some changes. We need to change that from .NET.SDK to .NET.SDK.Razor. Notice not Blazor, that has to be Razor in there. And then the other thing we have to do is we've got to add in here a root namespace to tell WPF where to pick things up from. And that root namespace just is going to be the name of our project. So that's going to be Blazor WPF client that we had there. So that is what we need to do inside our project. Let's give that a quick build just so that everything can bed in. And we'll notice immediately we're getting some errors because we do need to make a few changes to the files that we dragged over. Firstly, we've got to go into imports, and we can see that in there, the problem is that we're using the names from the old project. So this needs to be changed to Blazor WPF client. And also we're going to need to add in there a .components, and that layout should be .components.layout. So that should be sorting that bit of it out. Still got some problems, but rather few of them. We can get rid of that HTTP entirely. That was put in by default as part of the Blazor app, but we don't need it here, so we can get rid of that, and we can see the error disappears there. Next thing we've got to do is we've got to make some changes to the index.html. So here is our index. Things have got to change there. Another one, we've got to change that Blazor client to Blazor WPF client. That, remember, is where it puts all of the CSS from the CSS isolation files. And then also down the bottom here, you can see in a WebAssembly application, it uses the WebAssembly JavaScript library. We've got to change that to use an entirely different one, the WebView JavaScript library, which is there specifically, came from the NuGet package we added to make all of this work. So those are our changes to index. And then Really, we've just got to embed that into the XAML, really in much the same way that we already had when we look at that MAUI application that we had there, this sort of code here. So let's put that in there. So we'll go to our main window.xaml, and what I need to do in here is inside that grid, I'm going to say WPF : and then we have a thing called a Blazor web view. Again, this came in with the NuGet package and doesn't know where to find it. We can get it to generate that WPF namespace, so that's all that WPF was. Could have called it whatever we like, but that's what we've got in there. And then also on this one, we say host page equals, and then we've got to tell it where it's going to actually launch to Blazor, and that's going to be our www.root/index.html that we're just looking at. And then also on here, I'll explain a bit more about this later on, we've got to give it access to dependency injection. So on here I say services, and then that equals, and then we do a dynamic resource, and then just going to call that services. We'll see what's happening there when I do a bit of code later on. So that's our Blazor web view. Then in there, we're going to put this thing, which is a WPF and then Blazor web view and then root components. And in there, we're going to put a root component, which is what we can see there. And this is basically how we tell it how to start up the Blazor application. You'll notice you get lots and lots of warnings in here. It's a bit irritating. It's not very helpful as to what's going on, but it all comes out in the wash and should work by the end. So what we do here, we have a thing called a selector, and on that selector, we call that hash app. And that hash is simply the CSS for selecting by ID, because what we're doing here is if we go back to the index, you'll remember that with Blazor, we put in a div and we typically give it an ID of app, because that's where Blazor inserts whatever it wants to into the DOM at that point for the app. In the normal Blazor application, that was hooked up in the program, where here, that's where we did the same sort of thing. So having the root components and adding the app, but in the XAML, we do it slightly differently with that selector in there. And then the last thing we need to put in here is we say component type, and then we can just say what the type is. So we put in a type, and then that is going to be our home page, the one that we've got in there that's going to do all the business. Now we need to actually set up a namespace for that. There we've got our local, so we want to change that not just to the Blazor WPF client, but .components.pages. So that will give us all of that. And then in there, we can therefore just say local : home, because that's the only thing we've got in there. So that's what we've got in all of that. Still giving us these errors, in fact, rather than just warnings. But if we've got this right, those should come out in the wash. Actually, there's one I've missed off. We've just got to close that element. That will sort out some of those things, but it's still giving us some. And we've still got to do that thing with services. So if we now go to the code behind, so main window.xaml.cs, and in here what we've got to do is we're going to say var sc for service collection equals new service collection, because this, remember, is where we're going to configure the dependency injection. Now, we could at this point do anything like an add singleton or an add scoped and get services injected into our Blazor, but in this particular application, we don't need any of that. We just need to do one general thing, which is sc.add WPF Blazor web view. So that's what gets all of this stuff working. And then we need to say resources.add and then services. And then we do on the service collection, just do this build service provider. And that services there corresponds to the services that we put in there. And so that should have everything matching up okay. Last thing we've got to do is change the startup. So if we just go to configure startup projects, we don't want the Blazor client anymore. We want the Blazor WPF client. So click OK on that. And then if we hit F5, despite the fact that it was showing errors, and they've disappeared now, but it's now working, so don't be fooled. I mean, sometimes they are correct errors, but sometimes not. But what we can see, there we've got the web page that was part of the SignalR application, but here, there we've got now inside a main window. We've got to change the name of that, obviously, but that is WPF, but embedded in the WPF, we can see we've got our Blazor app, and we've still got that enter that is at an angle. So if we start working with this, say I put Harry in there, as we've seen before, click enter, well, at that point, we get an error. And this error is actually happening in the Blazor itself. And this is something that you'll find not just when you port a Blazor WebAssembly application into WPF like we've got here, but it also occurs sometimes if you had a Blazor WebAssembly application that you turned into Blazor Server. The thing is that when you're running in Blazor WebAssembly, you don't have a true multi-threaded system. That's not allowed in WebAssembly. And so when you get all these callbacks coming from the SignalR hub, like we have this on waiting for player, those in WebAssembly don't come in a separate thread. They simply get put onto the message queue within the browser, and then when they reach the end of the message queue, after any other messages like button presses and that sort of thing, then they get run in the main thread. And so when we do the state has changed, which is there to update the DOM, that's fine because it's in the main thread. But when we're running in WPF, or if we're running in Blazor server, you've got full multi-threading. And so this code is not running in the main thread, and therefore is not allowed access to any GUI elements. So what you have to do, very simple, you change your status change, you do a global replace, and you wrap it up with a thing called invoke async. And all that does is takes the call that you want, in this case the state has changed, and pops it onto the message queue so that it will get called in the main thread. So we're just going to say invoke async and then state has changed, and just replace that throughout the document, 5 places on each of those messages that was coming in. And in fact, although I've done that now, we got the error, it's generally good practice to do that from the start, even if you've got a WebAssembly application, because you don't know whether later on somebody's going to change their mind and turn what was WebAssembly into Blazor server, and then you'd have to do that anyway, so it's just safer to do that all the time. Okay, now let's run it up. And again, we'll drag these things over. So there we've got the browser-based one. There we've got the XAML-based one. We'll put Harry in here. Enter that. We can see it's working. We'll put Sally in there. And once again, in the umpteenth different way, we've got the ability to play that. But in this case, we've got it as a Windows desktop application, but with what I think is much simpler code, using Blazor embedded rather than what we had with the original WPF and having all of that XAML. But that really is just my opinion. If you've got a view of whether you prefer to use WPF or whether you prefer to use Blazor embedded, then do let me know in the comments. Obviously, it's going to depend on things like performance, depend on your existing code base, but it's something that's certainly worth considering if you've got a lot of skills in things like Blazor and HTML rather than trying to turn everything into WPF. So, hope you enjoyed that. If you did, do click like, do subscribe, and I'll see you next time.